resistant buildings. In this course, you will learn about the structural analysis and design of seismic-resistant building, using industry-grade software. This is the first module of your course, where you will be introduced to the basic concepts, in order to proceed with the course. In this video, you will learn about the seismic-resistant buildings, and their importance. And you will also learn about what is an earthquake, how to measure earthquake, and techniques to make the buildings seismic-resistant. So, let's start with the basic definition of seismic-resistant buildings. Seismic-resistant buildings are the structures designed to resist or control the effects of earthquake waves. Seismic-resistant buildings are needed to control and reduce the extent of damage caused by the earthquakes, and also increase the durability of the buildings. Let's take a look at the earthquake concepts, such as the definition, and how to measure the earthquake. An earthquake is the shaking of the ground, due to the sudden release of energy in Earth's crust. Every year, tens of thousands of earthquakes occur all around the world. Some cause tiny tremors, and some cause death and destruction, while some go undetected due to very less magnitude. Few earthquakes occur in remote regions which are inhabited. 95% of the earthquakes are caused due to the disturbance in plate tectonics. The remaining 5% is the other disturbances like volcanic eruptions, rock falls, landslides, and explosions. The surface of the Earth is made up of 21 major tectonic plates. Some of them are large, and some are small, that are constantly moving. When these plates are forced against each other, they deform, and eventually, they crush and fracture. The sudden fracture of these plates sends out a shock wave that causes the Earth's surface to shake. The magnitude of an earthquake represents the amount of energy released into the Earth's crust. It gives an idea about the strength of an earthquake. There are many scales to define the magnitude of the earthquake. Richter scale is a famous one among them. Richter scale is an exponential scale, which measures earthquake with respect to ground displacements. Every 1 point on the Richter scale is a 10-fold increase. So a 3 to 4 is 10-fold increase, and a 3 to 5 is 100-fold increase, which means 5 is 100 times more powerful than 3. The magnitude of an earthquake is measured using the displayed formula, where ml is local or Richter magnitude scale value, A is amplitude of the largest seismic wave, A0 is amplitude of smallest seismic wave, and delta is epicenter distance of earthquake. Different magnitude values have different effects on the structures. If the magnitude is less than 2, people will not feel these effects. We can only detect or identify them by measuring with the help of seismographs. Poorly constructed buildings will be damaged if the magnitude ranges between 2 to 6. If the magnitude is between 6 to 8, then most buildings would partially or completely collapse. Then the buildings will be subjected to greater damage, and they are likely to be destroyed. The intensity of an earthquake is a measure of how much the ground shakes during the earthquake. Usually, it is greatest near the epicenter, and gets smaller further away. Intensity cannot be measured using instruments. It is worked out by considering the effects of it on people and buildings. We can make the buildings seismic resistant by designing the buildings more stronger and more flexible. With the installation of shear walls, braced frames and moment-resisting frames, we can design the buildings stronger. Moment-resisting frames are the rectilinear assembly of beams and columns, with the beams rigidly connected to the columns. By virtue of the rigid beam-column connections, a moment frame cannot displace laterally, without bending the beams or columns. These are widely used in medium-rise buildings. A braced frame is a structural system, which is designed primarily to resist wind and earthquake forces. Members in a braced frame are designed to work in tension and compression, similar to a truss. Braced frames are almost always composed of steel members. Eccentric type of bracing is commonly used in seismic regions. Shear walls are vertical walls that are used to stiffen the structural frames of buildings. They help frames resist lateral earthquake forces. Generally, shear walls are used in high-rise buildings, where seismic and wind forces are high. Dampers and base isolation are the advanced seismic-resistant techniques. Dampers are the mechanical devices used to dissipate the kinetic energy of seismic waves penetrating into the buildings. The dampers reduce the energy available for shaking the building. This means that the building deforms less, so the chance of damage is reduced. Dampers are most suitable for skyscrapers and tall buildings. A tuned mass damper is a device, which is mounted in buildings, to reduce the amplitude of vibrations. A viscous damper is a hydraulic device, used to dissipate the energy of seismic waves, and cushion the impact between the structures. These are well suited for heavy load-bearing structures such as bridges, buildings, and mass structures. Friction dampers consist of moving parts, that will slide over each other during a strong earthquake. These dampers allow the building to move elastically, and dissipate the kinetic energy. Base isolators basically decouple the foundation and the superstructure, such that they do not pass on the damaging effects of ground motion during an event of earthquake. It is used as an advanced strategy to protect a structure from an earthquake. This technique is best suitable for medium-rise buildings, like public buildings. Rubber bearings are made from layers of rubber, with thin steel plates between them, and a thick steel plate on the top and bottom. These bearings are designed to be very stiff and strong for vertical load, so that they can carry the weight of the building. Friction pendulum bearings are made from two horizontal steel plates that can slide over each other because of their shape, and an additional articulated slider. However, the fact that they slide means that earthquake movements will occur mainly in the bearings. This completes the video on the introduction to seismic resistant buildings. Thanks for watching.